Hello students, in this video I will be going through some side to angle relationships within triangles. Let's take a look. Alright, so I have this triangle here, some arbitrary right triangle, and I'm labeling the vertices of the triangle with capital letters and the opposite sides with lowercase letters. And actually this is the convention for naming sides and angles. So typically when we describe the vertex, okay, of a triangle, we typically use the capital letters, and then when we talk about the sides opposite of said vertex, we typically use the lowercase letters. Okay, so I have this right triangle ABC, and what we're going to do, okay, is we're just going to make some observations by placing the sides in ascending order, meaning from smallest to largest. Okay, and then we're going to do the same thing with the angle measures, going from smallest to largest. Pause the video, see if we can do this. So hopefully you guys had some time to think about this, okay? By placing the side lengths in ascending order, just by observation, we can see here that side A here appears to be the shortest. And for sides B and C, it's harder to tell, right? But because this is a right triangle, we know that the hypotenuse will always be the longest side of the triangle. If you didn't know that, okay, you should try to get a sense of that based on like intuition, okay? So this opposite side, okay, hypotenuse is going to be the longest, so therefore C is going to be our middle. So in ascending order, it should be ACB. And then placing the angles in ascending order in the same manner, angle B here should be the largest because that is a 90-degree angle. Okay, and just based on observation, it looks like angle A is smaller than angle C. So again, the order should be A, C, then B. Notice how these things here correspond with one another, and we're going to get to this in a moment. Okay. All right, we're going to do the same thing, and with this triangle here, which is not a right triangle, it looks to be an obtuse triangle. And again, just by observation, okay, see what you can gather, okay, placing the side lengths in ascending order, and then the same thing with the angle measures. Pause the video, see if you can do this. So hopefully you guys had some time to go about this. By placing the side lengths in ascending order, okay, it looks like R is going to be the shortest, P is going to be the second longest, and then Q looks to be the longest of them all. And then going by the angle measures, okay, it looks like capital R is the shortest, capital P is the second largest, and capital Q is the largest of the three. And again, notice that these correspond in this manner. It is no coincidence that the largest angle will be opposite of the longest side, and vice versa. The shortest side will be opposite of the smallest angle. Okay, so with something like this, it's a little harder to tell, okay, but I did place the triangle on a grid. Okay, so again, pause the video, see if you can find out again the side lengths that is the shortest, and then the side lengths, and then the angle measures that correspond, that will be the largest. Okay, hopefully you guys had some time to think about this. Okay, because it's on a coordinate grid, we can figure out side lengths of A, B, and C without much hesitation. We can use the distance formula and determine that side length A is square root of 18, side length B is equal to 4, and side length C is equal to square root of 10. Knowing this fact, right, and knowing the observation that we had made just a moment ago, that the largest angle will be opposite of the longest side and so forth, we can then make the prediction that angle C will be the shortest length, right? So therefore angle C must be the smallest angle. And angle A is opposite of the longest length, so therefore angle A must be the largest angle. So therefore, in ascending order, angle C to angle B to angle A should be the order of smallest to largest. Which brings me to the observation that I want you to walk away with, okay, in this lesson, and that is the angle to side relationship or side to angle relationships. This is the generalization that we can make about about side lengths and angles within a triangle, and that is the largest angle will always be opposite of blank. The smallest angle will opposite of blank. Please take a moment and fill this out. The largest angle is always going to be opposite of the longest side, and the smallest angle will be opposite of the shortest side. Same thing could be said about it in reverse. The longest side is opposite of the largest angle, and the shortest side will be opposite of the smallest angle. Again, should you remember this verbatim, I do not encourage you to memorize this verbatim, but instead try to understand and understand this intuitively so that you do not have to memorize this by rote. Okay. So with these facts in place now, see if you can place the angle measures in ascending order. Pause the video for a moment, and then do the same thing with the second triangle there. Place the angles in descending order. Hopefully you guys had some time to think about this. Seeing that this is a 3, 4, 5 triangle, angle Y would be our shortest, would be our smallest angle, followed by X, followed by W. And then going with triangle HIJ, angle I will be followed by angle H, then J, or I, then J, then H. Because this is an isosceles triangle, J and H are going to be the same measure, so there's no difference in placing either one first. We're going to try and figure out what side lengths are in ascending order. Again, pause the video for a moment. So in ascending order, okay, we can tell that this angle over here should be 30 degrees because the sum of all the angles in the triangle should be 180. So therefore, HI will be the shortest length, followed by GI, followed by GH. However, I gave you that the notation before that the side length, okay, we often use lowercase letters, okay, and will be opposite of the angle, which is the capital letter. So this would be side length G, this would be side length I, and this would be side length H. So again, in ascending order, it should be G, followed by H, followed by I. Then looking at this triangle over here, all three angles should add up to 180. So therefore, I add this up and set it equal to 180. Solve for x, and I end up with x is equal to 42.5. By placing x back in, I can then determine that angle C is 42.5, angle B is 52.5, and angle A is 85. Knowing the angle measures of angle A, B, and C, I can then determine the side lengths in descending order, which means I'm placing the longest side first, followed by the second longest, followed by the shortest. Since angle A is 85, side A will be the longest. Since angle B is the middle, it will be followed by side length B, and since angle C is the smallest, the shortest side length of the triangle will be side length C. Can a triangle have side lengths equal to 3, 3, and 6? Why and how do you know? So this is an extension of the ideas that was just demonstrated regarding angle to side relationships. Pause the video to see if you can answer this question. Can a triangle have side lengths of 3, 3, and 6, and why? Hopefully you guys had some time to think about this. The answer is most definitely no. The sum of any two sides of a triangle must be greater than the third. Think about this almost like a bridge, okay, opening up from both ends, right? If this is 3 and this is 3 and this whole length is 6, these sides will just collapse onto to form a linear pair. And that wouldn't form a triangle at all. So triangle ABC have side lengths 2, 5. What is the range of possible side lengths for side C? Knowing what was just discussed now, let's try to determine a way for us to figure out a range of possible side lengths for side C. Pause the video to see if you can figure this out. Hopefully you guys had some time to think about this, okay? The best way to demonstrate this is I'm going to draw a series of different triangles to demonstrate this idea. I know that side length A is 2 and side length B is 5, and I'm going to draw these side lengths in their extremes so that you can justify for yourself why the range of C is the way it is. So what I'm going to do is I'm going to place side length A and B as a linear pair first. Okay, so again, this is A and this is B, and I'm placing them on a straight line to demonstrate to you that the third side cannot be equivalent to a length of 7. And actually, it must be lower than 7. It cannot be greater than 7 either. Right? Since the full length of this is 7, the third side must be lower than 7. It cannot be greater than 7. It cannot equal 7 either. So if I were to take side length 2 and begin to rotate this, okay, thereby forming a triangle, continue rotating this, okay, we can now see that side length C is going to be less than 7, okay? This has to be less than 7. However, there has to be a value like the other extreme, right? Let's see what would happen then. So in this case, I'm still rotating. This is still less than 7. I don't know what the other extreme is yet. Hopefully by now you're beginning to see where I'm going with this, right? What do you think the other extreme would be? Right? So side length C must be less than 7. And I'm getting closer to that other extreme, right? So if side length 2 were to lie flat on side length B, side length C therefore must be greater than 3. And this would be true going in the other direction, right? So side length 3 must be greater than 3 but less than 7 all the way around. So how do we conclude this, right? So these are the two sides that are given. The third side must be less than the sum of the two sides. The third side must also be greater than the difference of the two sides. This is our triangle inequality theorem, that the sum of any two side lengths must be greater than the third side length. So again, the sum of any two side lengths, okay, so if I talk about side length C here, it must be smaller than A and B. Side length B must be shorter than the sum of A and C. Side length A must be shorter than the sum of B and C. However, this is not, this doesn't tell us the full picture yet because there is a range of possibilities for what each of these side lengths must be greater than, right? So side length C must be greater than the absolute value of A and B. And why am I putting the absolute value here? Well, let's just say if side length A was shorter than side length B, okay, then it wouldn't make a difference when we do the subtraction either way, okay? That's why the absolute value is there, right? The whole purpose behind having the absolute value symbol is so that when we find a difference, if we end up with a negative number, we just make it positive, okay? But the whole point is to find out how far away the two numbers are away from one another. That's all it is. Side length B must be greater than the difference of A and C, again in absolute value, and side length A must be greater than the difference of B and C. Triangle ABC have side lengths, I'm sorry, this should say PQR, so triangle, not ABC, but PQR, have side lengths of P is equal to 10, Q is equal to 6, and what is the range of possible side lengths for side R? Well, knowing and understanding the triangle inequality theorem, we now know R must be less than the sum of those two, right, which is 16, but greater than, do you see how we can either write it as 10 minus 6, or if we do 6 minus 10, do you see how the absolute value of this is the same as this guy, right? So again, R is less than 16, but greater than 4.